I'd just like to introduce myself, and then we're just going to go across and everybody else can introduce themselves, and then we'll get into the subjects of the day. For those of you who have already been onto the internet and seen the subjects, and for some of my panel members who've been swatting hard on them, I'll just repeat what we're going to talk about over the next hour. We've got the interpretation of the rule book, we've got aerodynamic concerns, the development of energy recovery systems, driver safety considerations, and drivers' skills versus advancing technology. So what we'll try and do, or what I'll try and do, is keep people as much on track as I can and throw a few hand grenades into the proceedings. And I think we would certainly welcome any questions that you've got, almost probably as we go, I think, to make it as reasonably interactive as we can. Okay, so let's start. I'm Tony Parker, Professor of Industrial Design at Massey University. I'm not an engineer, so don't ask me a whole lot of really nitpicking technical questions, because I'll just shove them over this way. And I've got a lot of colleagues here, so I'll get them to introduce themselves. Dave?
Yeah, good afternoon. My name's David Lovegrove. I am an engineer, a mechanical engineer. I like to
ask him difficult questions.
I like to classify myself now, though Tony is a designer. And I trained in New Zealand at University of Canterbury, Bachelor of Engineering, and really what happened was I wanted to be a race car driver. I wanted to be a Bruce McLaren and drive in Formula One, as I'm sure every young New Zealand boy wants to. And I quickly realised that wasn't going to happen, so the next best thing was to work in Formula One, and luckily I got there. Worked for Tyrrell in the last 2 years of Tyrrell's life, 97 and 98, before it was bought out by British American Racing. And principally my roles, I was initially just in there as an engineer to support the team, but was sort of thrown a hospital pass and became through one of the senior designers being poached by another team. I was asked to fill in because obviously there's a critical time frame to get a car onto the grid, and for the next year, and I was responsible to try and keep the progress happening with the car, and was until someone was supposed to take my place, and that never happened. So I ended up being responsible for all the bodywork on the car, making sure that the car complied with all the regulations, and also I interfaced with the aerodynamics department, and I was responsible for the under tray and underbody aerodynamics.
Bob,
off to you, mate. Craig.
Yeah, my name's Craig Russell. I've been following motorsport since young fella, back in the end of the 70s. How does this go? I started life dirty hands, and still am to a point. Fascinated by motorsport because of the machinery. Likewise, I wanted to be a driver. I had insufficient money and insufficient talent in equal measure. and frankly, I reached the point when I realised that what I loved was the machinery. It fascinated me. And it was a natural progression that through various trade skills and stuff that I had, I went overseas. I did a couple of years in Formula 3. Fortunately, Mark Webber was our driver that year. Went on then to work for Stewart Grand Prix, who became Ford, who became Jag, who are now Red Bull. So it's really nice to see to see Mark at the top. Now, when I came back from overseas, what I'd seen, the attitudes that I'd experienced, the approach to racing was very much in the forefront of my mind, and I helped a lot of people running their race cars as a mechanic and as an engineer. And as time went on, I gained a stronger and stronger idea of how I would like to see things done. That culminated in me owning and running my own race team and helping drivers, learn and try and achieve as much as they could. I'm out of it full time now, but I still have an interest in as an engineer. Again, based here in New Zealand, playing with cars. I guess I have a slightly different approach because it's ground up, it's practical, it's racing. Engineers are able to fill in the gaps for me. I don't need to care so much about it. So I guess what I understand very well is how systems interact and how to push through, see what's important, what's not important, how do you achieve what you want to achieve.
My name is Bob McMurray. I'm nowhere near as clever as these guys, and I'm a race fan. That's it. Especially Formula One.
Okay, well, let's perhaps
Bob's
make a
been in
start.
Formula One a lot longer than any of us, though.
Yeah, well, I'm actually only 25. I just looked at 85, that's all.
I think we better make a start, guys, on some of these issues so that we can get stuck into it. And I thought that I'd just preface the first part, which is the interpretation of the rule book, by saying that the name Formula One actually is an interesting one, because what it's really talking about is a formula for a car, and number one because it's the top one. So the formula for the car comes from the rule book, and originally I think it was called the Little Yellow Book. It's a bit like something that somebody out of China might have written, except it's yellow and not red. But it sort of gives you a heck of a lot of very specific details about what you can, what you can't do, and what's legal and what is illegal. And I thought it would be kind of interesting just to start off our conversation today to ask David, because he's the man who's actually drawn some of these things, designed some of these things, just to talk to us about how that rule book is actually used to start off with to actually design a Formula One car. So, David, if you could just talk us through that one, that would be great.
Well, hospital pass to begin with. I suppose the first thing is that, you know, a lot of the constructors and the teams, they like stable rules, and by having stable rules, obviously they can get to a point to understand the car and they can evolve the car. What happens is that when new rules come about, obviously it's an opportunity for teams that aren't at the pointy end of the grid to make some big advances, and they can do that. Obviously that gives them an opportunity, levels the playing field. But principally the rules are actually, and particularly recently, have actually come about to try and reduce costs, and over the last probably 20 years have really been about almost slowing the cars down, because they are getting too fast, and principally that's because they're now becoming were becoming too dangerous. And as such, rules, there was a huge expansion of the rule book around safety, and I think we're going to talk about that a little bit later. But obviously you get good visibility of the rules. The teams obviously are supposedly involved in the making of the rules and of agreeing to the rules, and you've probably seen a lot of politics in the last, particularly this year, where the teams are not agreeing with what's actually happening, in terms of what the rules are actually, the rules that are coming up with. But so there is a certain amount of visibility that the teams have with the rules, and obviously you have to plan very well around that. And it doesn't matter whatever the rules are, the teams are always out to try and exploit them to the maximum letter of the law, and work around them. And so with that visibility, you obviously have to interpret the rules. There's a lot of internal discussions within the team in terms of the design process on the different areas of the car and aspects of the car that are going to be affected by the rules. And obviously, you know, you actually develop a project plan almost around you know, what needs to be done in order to bring a car to the grid that complies with the rules. And so every rule obviously gets interpreted and essentially designed for. And you know, certainly when I was there, the design process and what we used to do is we obviously had an envelope for the car. By an envelope, essentially, it's essentially the shape of the car and the footprint and the profile and things that it has. We have that all modelled up in computer, and essentially what I was doing was looking at all of the geometric parameters of the rules where you could and couldn't put things, and we actually had a model in the computer or the CAD. That had all of those rules laid out in essentially 3D, and we would obviously then look at that in terms of how the car could and could not, or you know, where it would fit within the rules and the opportunities that we would then be able to see that we could design around.